So this first talk I'm going to split with Erik. We're going to talk about the project that we have on the go on Vancouver Island right now, which we've titled Mitigating Tire Wear Toxins to Protect Salmon on Vancouver Island. So this project is in collaboration with BC Conservation Foundation, obviously VIU, and then we're also working with the University of Victoria. We have funding. The largest funding we got was through the BC Salmon Restoration Innovation Fund this year, but we've also had the help of Pacific Salmon Foundation, Regional District of Nanaimo, MyTax, and quite a few others. So just to kind of introduce some people that you're probably going to see all the next 2 days. So that top row is the VIU crew that we've been working with. Jameson and I are just a couple of the faces at BCCF. There's a handful of other biologists you'll probably meet throughout the next couple days that might pop in once they're done in the field. Just to give you a really quick introduction of who BC Conservation Foundation is, for those that don't know, I work in Nanaimo at the Aquatic Research and Restoration Center, but we do actually have 2 other offices in the province. The other 2 kind of focus on our Wild Safe Land for Wildlife and wildlife collision prevention programs, whereas our office on the island is very fisheries focused on research and restoration projects. So our project has kind of these 3 main objectives. The first is what and where are the major sources of tire wear toxins on Vancouver Island. The second is how do these concentrations change over time and space. And then the last is how can low-cost nature-based solutions protect these urban streams from tire wear toxins. So Erik and I are going to kind of focus on these first 2 today. So just to give you a kind of glimpse of Vancouver Island, all the waterways. So this is kind of all the systems on Vancouver Island, not just salmonid systems, but this next map kind of gives you an idea of all the red lines being all of the highways, then the blue lines being kind of the major systems. All the green dots represent every point at which a road intersects with a salmon-bearing stream on Vancouver Island. So as you can see, there's about 10,000 or more spots that we're able to sample, so there's no shortage of places to actually do our work. So this is just a closer look at, I think this is in Nanaimo, that, as I said, there's really no shortage. So one of the first things that we're doing is a wide-scale surveillance, and I just want to say, without the help of all of these groups on the screen, and I don't think I've missed anybody, but they're the ones that are going out and doing the bulk of our sample collection. So we're sampling between Campbell River and Victoria this year. We have 30 different groups that are working with us, stewardship groups, First Nations groups, up and down the island, and without that, we really wouldn't be able to work in that geographic range. As everybody knows, Vancouver Island is full of microclimates, so it makes it really challenging to actually try to capture these rain events when they're happening, and when you want to actually collect the samples. So without them, we definitely wouldn't be able to do this. We also lean on them a lot for the site selection because they work on all these systems continuously, so they know them the best. They know what's safe to access, and they know where they can get in, where it's not dangerous to, but also where they can see the actual runoff coming into these systems and see these impacts. So as I said, we're working along the east coast of Vancouver Island to do all this sampling. We realized really quickly that we were going to have a lot of samples in a really short time frame, and we needed to find a way in which we can work around that, especially the data input, because everybody here knows how time intensive that can be. So Joseph is going to talk a lot more to kind of the implementation of the sampling and things tomorrow, but he developed this data collection app for us so that we could put QR codes on all of our bottles and all of our sample locations so that we could standardize everything and make it really simple, so that it can the lab crew already has all the data as soon as I'm dropping off bottles, kind of the day of or the next day after samples are collected. And then we drop all of the samples off at VIU to do all of the sample analysis. Joseph will touch base on this auto sampler as well tomorrow to really highlight the high throughput that we're able to do. They do all of the data processing for us, and then we also are building these maps that we hopefully, actually just released the database, which we'll show a quick snippet of at the end of this, but the hope is that we can use that as an advocacy tool to share all the results with different levels of government, the community, everybody, so that you have an understanding of what we're finding, as well as a means of just giving the feedback to the different stewardship groups so that they know what their results are. So we're using all of the results that we're getting from our wide-scale surveillance to actually inform some of these other projects that we're doing at looking at changes over time and space. So we want to make sure that we're putting those efforts, those higher sort of people efforts, on systems that we know we're actually going to see 6 ppdq, so we can actually assess these things. So we're doing more intensive frequency sampling, on some of these systems that we're seeing continuous 6 ppd show up in all of our samples. And then we're doing increased spatial sampling to get a better idea of distribution, where some of these bigger point sources are within the actual system itself. So far, since September 2023, we've captured 6 rain events, we've collected over 2,000 samples, and we're seeing a detection frequency of about 33%, keeping in mind that we're collecting before, during, and after a rain event. So those befores, we're not really seeing much in the way of any results. And we're also collecting field blanks in the field just to see if there's any sort of contamination. So yeah. So as I said, we have 30 groups working with us. Over 150 volunteers have been trained this year. Over 670 volunteer hours have been put into the project this year. I think the numbers that Deb gave this morning were a little bit the last ones that we gave her. So we've looked at 56 systems and 123 sites this year between Campbell River and Victoria. We've done 2 high interval rain events that we've been sampling at 3 different locations in Nanaimo. And we've seen 6 ppdq detected in about 660 of the samples. So as I said, 33%. So about 100 of those stream samples were above the juvenile lethal concentration, which is the 41 nanograms per liter. And then about 50 of them were seen above the adult coho lethal concentration of about 80 to 95 nanograms per liter. So with that said, that's a lot of samples. So I'm going to pass it over to Erik so he can kind of explain how they go through all of the huge samples and bottles that I drop off all the time.
Thanks, Haley. I'll just say a few words about the engine that's behind the generation of the numbers, and I'm just going to do a high-level version of that, and tomorrow we'll have a few presentations that will provide a bit more detail about that end-to-end automation. I work with Dr. Chris Gill as co-directors of the Applied Environmental Research Lab, and one of the things that we do is use mass spectrometry as an engine to study both environmental problems as well as classical analytical chemistry problems. And we also use it to study material and physical properties. And these days we're also doing more and more bioanalytical type work. The driver here is to develop and apply some novel analytical methodologies that allow us to get faster, better, cheaper results. And this is particularly useful in a wide-scale surveillance program. Haley mentioned that we've analyzed about 2,000 samples. It's now over 2,000. But if you think about the number of actual analytical measurements, it's closer to 4,000, because every time we measure a sample, we're measuring quality control samples and analytical standards. We're also doing triplicate analysis on any concentration of 6 ppdq that comes in as a hit. That is, if we detect 6 ppdq, we take that sample aside, we measure it 3 times. So when you're doing that number of measurements, you do need to have a speedy technique. And so one of the things that we've done is automated this process so that we can make these measurements in the order of minutes to hours and then report those results back on the order of a few days. And so that it really helps with our citizen science groups, because they can actually see the results as they're coming in. In fact, we've had a number of situations where we've adapted our sampling program based on the results we're seeing. So the morning of, we're making decisions as to where we're going to sample that afternoon. This is just a close-up map of the Greater Victoria area or the Nanaimo area, just showing all those red dots are urban stream major roadway crossings. So as Haley mentioned, there's no shortage of places to look. Of course, to do this with any relevance to these very relatively sensitive species, we need to have be able to measure low concentrations. Many of you may be familiar with the term part per million as a measure of concentration. That's 1 milligram of a material in a liter of solution. But you've heard from the 2 presentations this morning that coho are sensitive at the parts per trillion level. or nanogram per liter concentration. So if you take a part per million and you take 1/1,000,000th of that, now you're in the concentration range that is relevant. So we need to be sensitive to make these measurements. This is a classic needle in a haystack problem. Of course, stormwater and stream water is very complicated. There's lots of other things in that stormwater, and so this really does become a challenge. These are examples of photographs of some of the streams during storm events. You can see that looks like chocolate milk or cream coffee. There's a lot of turbidity, that is suspended solids, and a lot of other suspended and dissolved materials in these samples. There's also more than one potentially toxic compound. This verdict is still out on some of these structural analogs. This structure here at the top is 6-ppd quinone that we've been talking a lot about today. But if you think of these groups that are hanging off on the side, if you vary them, this one's got an extra carbon on it. And if you look at on the other side, this one's got another phenyl ring on it. These are all what are called analogs of 6-ppdQs, and they come from analogs of 6-ppd. So tires are often produced with a mixture of these anti-ozonants that you heard about this morning. And so there's more than one quinone that could potentially be coming off of those tires. And we do see a number of these. We measure them all at the same time, as many other labs do as well, but we want to find out about them going in. So our technique is just a very quick, there's a sample, we dip a probe in, that probe has a membrane in it, and that allows our analyte to permeate through the membrane, and then we directly go to a mass spec. It's a trade-off. We're not doing chromatographic separation, but we are getting the result in a hurry, and we can make some important decisions based on those results. We can also measure concentration changes dynamically in real time. So if we're interested in studying treatment systems and different sorption processes, in fact, we've done some of this you'll hear about tomorrow, we can actually do that in real time on the bench and make important decisions about, say, the kinetics, that is how quickly these things stick around in solution. So the data is structured, so that means not only can we analyze them and work up the concentrations quickly, but remember all those samples come in with a QR code from our team of volunteers, and so we know that the date and the time and the location that those samples were collected, and so we can take that data and we can run it all the way through the analytical process, do the quality control, and then generate a map. So right now we're doing this all on the order of hours. So samples that come in the morning can generate a map by the end of that day. And where we're heading with this in the future is to take build off some of the expertise that we've developed in our group over the last decade or so, which is to take the lab to the sample rather than bringing samples to the lab. And so this is our mobile mass spec lab facility. It's a Sprinter van that's been purpose-built. It has a mass spectrometer in it, and one of the things that we're going to be doing this fall is parking near some roadways and making those measurements in real time as the rain is falling. I do think that we have some real opportunities to answer some really important fundamental questions, but also to think differently about how we do environmental assessments in general. This is just an example. This is a screenshot of our interactive data dashboard. So this is just showing the concentrations right now of 6-ppdQ on the southern half of Vancouver Island. The size of the dots and the color of the dots is related to the chemical concentration. So those larger red dots represent a concentration. If you wanted to find out where that was, are we live on this?
You're live on it. Yeah.
Do you want to do this part? I think you're more familiar.
Yeah, so this is the database that we've just launched, I think, at the end of last week. So it's kind of got the 4 tabs. The first, this is showing all the maximum concentrations that we've found up and down the island. As Erik said, the bigger the circle and the darker the red, the higher the concentration. So as you're kind of seeing these urban centers, we're seeing those bigger concentrations. When you actually zoom in, that chocolate milk that he showed you is Northfield Creek. So if you click on Northfield Creek, it'll give you an idea of all of this data that was collected there, each of the samples. If you click on the graph, it'll show you the graph at which of all the samples that were collected there and what the concentrations were. A few other places throughout the day if you want to play around with it, up on in the atrium and things. But yeah, so then there's just a few other ways that you can play with the data. There's the daily occurrence, so you can actually look at if it'll load. You can look at what was collected that day. So in this list over here, the darker the blue, the higher amount of rain or precipitation that there was. So this is what was all collected on September 25th. The point source will be very similar to the first one, but it'll be specific to collecting from point sources as opposed to creek sources. And then there will also be a data interrogation tool, which, again, when it loads, there's kind of 4 screens off the left side that you're able to actually go in and look at how the concentrations vary, because that's a question that I get a lot from the different volunteers is, how does our creek stand up to the one in Victoria or something else? So then you can actually play with the data and get a better idea. Yeah.
So we're hoping that those of you that have been working on the field collection here and have connections to the local streams can spend some time interrogating this for a couple of reasons. One, this is a beta version, so we'd like some feedback as to how we can make it more user-friendly and improve the instructions. But also for you to give us some feedback and think about in terms of future sampling and both sampling locations and frequency.
Right. I think that was it for us.
Yeah, that's it for us.
Keep it short and sweet.